Let me just say it. Solving calculus questions in school curricula and exams is not much different from solving algebraic equations or trigonometric equations. We all know how those equations require extensive and instant application of all the relevant algebraic identities and trigonometric identities, as also how that mastered application is secured and honed through continuous and creative practice, iterations. However, that said, it is the reverse capability that is really prized and offers competitive edge and joy, reading the reality that the questions represent or could represent. This is conceptual wisdom and the only valuable ability in the AI age. Another point that must be emphasized is the high practice-centric nature of calculus education and evaluation in exams. This reflects a historical misapplication and an unchanging educational commitment over the past 200 years. In his 1823 book, French mathematician Augustin-Louis Cauchy finely articulated, rigorized, and methodized calculus, leading to remarkable gains for engineers and scientists. Unfortunately, that was not for educating children and young adults. And we continue to live that choice made nearly 200 years ago, when the current K-12 school format was made the default. To the point, the practice and postulates in calculus must not be this harshly divorced in school education. Fortuitously, conceptual calculus is a joy, the real-world mathematics. Of course, there has to be a catch if calculus is intensely real-worldly and only a minuscule fraction get that. Overwhelming majority of mathematics teachers lack a narrative. To me, there is formidable friction at the connection of the real and the mathematical expression. Substantively, that is why calculus education starts and ends at limit and continuity, for most in the school years. Jumping the gun, to come to what matters, the resolution of the poor state of calculus education, the minimum common action is two-legged. First, limit and continuity need a completely new conceptual narrative away from its method phase. Second, we must publicly acknowledge the reason behind practice being critical to calculus. Now, while the lessons ahead bring this out, hopefully, loud and clear, I must present quotable quotes of mathematicians to bolster my case, my narrative of calculus. God does not care about our mathematical difficulties. He integrates empirically. This is an example of how real calculus is. To me, it is the more incisive version of the popular saying that mathematics is the God's language, the means of threading the universe in a common language. Calculus works by making visible the infinitesimally small. This is why it is the language of all changes and the means of covering curves. Hard to be a physics major at Rice University if you have flunked calculus. In the fall of 1972, President Richard Nixon announced that the rate of increase of inflation was decreasing. The first time a sitting president used the third derivative to advance his case for re-election. This is just to show the nuances of calculus playing very close to our lives. We fail to see calculus as the actor. Science is the differential calculus of the mind, art the integral calculus. They may be beautiful when apart, but are greatest only when combined. And I may add that this is stated with authority. Ronald Ross was a polymath, wrote poems, several novels, and composed songs, besides being a mathematician and an artist by choice. We must bring conceptual calculus back into focus is crucial. Inventive understanding of theoretical basis, reasoning, and principles that govern limit and continuity is important. Practice around practicing calculus must be open and sharp. That is, we must know practice is for solving and much less newer insights of calculus. Conceptual calculus represents the calculus needed in the AI age, outcompeting AI in more accurately mathematizing given situations. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.